Hello, I'm back with another video about a solution for one of the questions in a previous quiz about series and sequences. For this one, we are asked to find the exact value of 2 over 1 factorial minus 2 squared over 2 factorial plus 2 cubed over 3 factorial and so on. So basically, the numerators are powers of 2, starting from 2 to the 1, and then the denominator is uh, 1 factorial, 2 factorial, 3 factorial, and so on. So that's like a geometric series, except that this time we have factorials. This is actually easy for some, if they're familiar already with power series. But for especially for high school students, this might be a topic that is not yet covered, so it might be a new thing for them. So I hope this video will help you understand at least what this series is about. To be able to answer this, we have to know that the exponential of x, e to the x, is equal to 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial and so on. Without knowing this, it's almost impossible to find the answer to this one by hand. So this right side, we can write this in sigma notation as the sum of x to the n over n factorial from n equals 0 to infinity. Now let's assume that we are familiar already with this series. This is quite similar to the given expression, because if we let x equals 2, we will have here something like 1 plus 2 over 1 factorial plus 2 squared over 2 factorial plus 2 cubed over 3 factorial and so on. What's the difference though? There's a difference in that the required series starts with 2 over 1 factorial instead of 1. And also the signs alternate. There's a quick way to account for the alternating sign, and that is to negate x or replace x with negative x. If we do that, if we go back to the original equation, we get here e to the negative x equals 1 plus negative x over 1 factorial plus negative x squared over 2 factorial plus negative x cubed 3 factorial and so on. Note that if we simplify the powers of negative numbers, every even power results to a positive coefficient, while odd powers result to a negative coefficient. So we have here 1 minus x over 1 factorial plus x squared over 2 factorial plus or minus x cubed over 3 factorial and so on. If we substitute here x equals 2, we get e to the negative 2 equals 1 minus 2 over 1 factorial plus 2 squared over 2 factorial minus 2 cubed over 3 factorial plus and so on. To get what we want, we just subtract 1 from both sides to get e to the negative 2 minus 1 equals negative 2 over 1 factorial plus 2 squared over 2 factorial plus 2 cubed over 3 factorial. Oops, again, that's a minus, and so on. Now to get what we want, just get the negative of the expression. So what we want is the negative of 1 minus, e squared, or e to the negative 2 minus 1, which when simplified is negative e to the negative 2 plus 1, or 1 minus 1 over e squared. Therefore, the series that we want is equal to 1 minus 1 over e squared, and that's our final answer. So again, we just started with the power series here, this power series here. And then we just did some algebraic manipulation to result to what we want, to the series we want. Okay, I hope this is clear. And I hope you learned something from me today. Thank you for watching and see you on the next one. Bye bye.